Concept 3, special cases of absolute value inequalities. So just like with a normal equation, an absolute value equation, you can have special cases where you don't have a constant or a number as a solution. Right? So if we have an absolute value, anything that comes out of that absolute value is going to be positive. If we're saying that that absolute value is equal to a negative, well, there's nothing we can put in here that'll come out and equal a negative number. So this is always going to have no solutions. Right? That's one of our special cases. When you have an inequality, it's going to look very similar to this. Okay? An inequality, when you have an isolated absolute value, okay, so when your absolute value is alone, when we don't have numbers right there, and whatever is on the right is negative, is going to be one of those special situations. Okay? It's not automatically a no solutions answer, okay? But it could be. It depends on which way the sign is pointing. All right, so if we come through and we isolate my absolute value, I have x plus 1, I add 3 to both sides, those cancel, negative 4 plus 3 is going to be a negative 1. Okay, so I've got my absolute value isolated, and I've got a negative on that side. Okay, now whatever value I put in here for x, once I add 1 and do my absolute value, is it going to be greater than negative 1? Yeah, always. Doesn't matter what number I put in there. I can put in a really large positive number or a really small positive number. I can put in 0. I can put in negatives. Whatever I put in here, it's going to come out as a number that is larger than 1. Right? It's going to be greater than 1. So my solutions to this is all real numbers or infinite solutions. Okay? Because any number in here will result in a number greater than negative 1. All right. Now if we have the opposite, okay, I've got to, again, isolate my absolute value. Subtract 2, the absolute value of 3x is less than 1 minus 2 is negative 1. So I've got my absolute value, it's isolated, and I've got a negative number on the right-hand side. So that tells me I'm in one of my special cases, and now I've got to look at the sign. Okay, if I put a number in here, is there any way that I can get this answer after it comes out of the absolute value to be less than negative 1? And the answer is no. There's nothing I can put in here to make it less than negative 1. Right? I could put in 0, 3 times 0. Well, 0 is not less than negative 1. 0 is greater than. So I could put in negative 1. 3 times negative 1 is negative 3. But then the absolute value turns it to positive. Positive 3 is greater than negative 1. I could put in a positive number, but I just get a larger positive number. So there's nothing I can put in here that is going to get me a number less than a negative. All right, which means that the answer to this is going to be no solutions. There's no number I can put in there. One last thing is you need to be careful on your greater than, okay, because it is not necessarily going to be a negative number. It doesn't have to be. It could also be 0. Okay, if I had a absolute value equation that was greater than or equal to 0, okay, this isn't negative, but if it was greater than or equal to, it could still be all real numbers, right? Even if I put in 0 here, it would be greater than or equal to 0, right? I put in a negative, well, that's going to be greater than or equal to 0. So in this case, I will still have all real numbers or infinite solutions. Okay? However, if I had the absolute value of x greater than 0, all right, I am not going to have all real numbers as a solution because x could be 0 and 0 is not greater than 0, right? 0 is equal to 0. So my number line would look like a compound inequality where I have my open circles on 0 and 2 arrows going either way, right? So it could be any number but 0, okay? So these are two kind of special cases that you've got to make sure that you look out for. Okay, you won't see them very often, but if you do, that can throw things off.